The next topic is logic development. So we have the inputs and outputs. We define the inputs, define one output, and now I will develop the logic. Let me adjust everything here. For function, I need a flip-flop or prior flip-flop. I just put the flip-flop here. We need the OR block here and two NOT blocks in order to invert the logic. Invert the logics, and we use them to reset, because the emergency stop and stop, they are active signals, and normally they are true. This is the emergency stop, and this is the actual stop. And we need one of these start signal. I will complete this symbol for this project. I will tell you how to do this symbol, complete the symbol table, or even if you want to update the symbols afterwards, it can be done very easily. And inputs are connected. Let me connect the output from here. We have only one output that will energize the motor. So the logic is developed here. So the logic is developed here, and there is possibility of doing function tests. We have offline simulation in order to do the basic test before actually purchasing the hardware. So we do the basic function test here, and after successful simulation, we will buy everything, all hardware. We will purchase whole hardware and do the tests in actual hardware. So this is the start simulation mode. If you don't have the hardware, you can simulate the whole logic with software. So you can see that as we don't have the actual emergency stops and the stop button, so they are normally, they should be true, but for simulation we only have them in false. So we just make them true. Now it's possible for us to run this safety contactor in order to enable the contact. It possibly is a relay, safety relay is enabled, and safety relay will run the contactor corresponding to that drive or motor. So it's a flip-flop. The start can be a momentary button, so if, the motor is running until you don't need that, and you can press a stop button. A stop button can be a button here, momentary button. It's NC. If you push, just the output will be de-energized, and we can run again and stop. Consider a case that the start is latching. There is a problem with the start button. Something happens, and the motor is turning off, and again stop is getting normal, or emergency stop is getting normal. When you just remove the emergency stop, the motor will be started again. It's something that we will avoid in actual industrial cases. In industrial application, we need intervention, operator intervention in order to run the drive again, because it may cause some damages. We want somebody to inspect everything, and if everything is okay, the operator will press some button and the motor will start again. It's crucial and it's needed. We will discuss that later. In the next video, we will implement and alter the logic in a manner to include the operator intervention. We will discuss something else. Some of the operation team or some engineers are very familiar with the cause and effect table or cause and effect matrix. We have this option in this Flexi Soft Designer. You can do the function test simply by selecting IO matrix, and you can do the simulation or the actual test when you want to do the actual test. All these buttons are inputs from field, and you need to push them from field. So consider we don't have all signals, all emergency signals are false, so it's not possible to run. The first condition should be turning on, or unlatching the emergency buttons, and just after that pushing the start. It's very easy to do the function test by the IO matrix. It's very helpful for very complex logic possibly. I will pause the video here. We will alter, or we will change this simple project and make it more like actual industrial application.